In the last video, we studied about latent heat, and today we're going to solve a problem, and as always I'm going to post the problem down in the description. So a 3-gram lead bullet at 30 degrees Celsius is fired at a speed of 240 meters per second into a large block of ice at 0 degrees Celsius, in which it becomes embedded. What quantity of ice melts? Okay, so here on the board we have the values listed. We have the mass of the bullet, then we have the initial temperature of the bullet, then we are assuming that the final temperature of the bullet is 0 degrees Celsius, since an equilibrium will be established between the bullet and the block of ice if we're looking at it as a system. So basically, as we will see, all the energy will be dissipated from the bullet into a block of ice. Then we have the velocity of the bullet, then we have the latent heat of fusion of ice, and then the specific heat of lead. Now here we have the lead bullet, and we know that it gets embedded into the block of ice. So we can say that all the energy from the bullet is transferred into that block of ice. So that will include the kinetic energy of the bullet, so EK, plus, now as we saw, the final temperature of the bullet is 0 degrees Celsius. So basically, since the temperature decreases from 30 degrees Celsius to 0 degrees Celsius, we can see that basically heat is dissipated from the bullet into the block of ice. So also heat is transferred from the bullet into a block of ice. And this will be equal to the latent heat of fusion of ice times the amount of ice that will be melted, or the amount of water that will be yielded as a result. Now if we plug in the values, for the kinetic energy we'll calculate that that's equal to, let's see, 86.4 joules. Now for the heat that will be dissipated, this will be equal to the mass of the bullet times the specific heat of lead times the temperature difference, which is 30 degrees Celsius, and this will be equal to 11.52. And for the latent heat of fusion of ice, we have that it's equal to 3.3 times 10 to the power 5. So this is equal to 3.3 times 10 to the power 5 times delta M. Now if we calculate this, and if we divide both sides by 3.3 times 10 to the power 5 for the amount of water that will be yielded, as a result we will get that it will be equal to 0.9296 grams, and we are done. In the next video we're going to study about heat and work in thermodynamic processes.